welcome to this collaboration between the Clinical AI Interest Group and the Data Science for Mental Health Interest Group. And it's really exciting to be doing this kind of collaborative activity together. I think there's so much that we can learn from each other, and hugely excited to have Jenny Chim also chairing, and also Maria Liakata speaking to us later. Hugely excited to hear her talk. Just a few updates from the clinical AI side. So the summer school is going to be on the 20th of July, and really excitingly was oversubscribed. So we're just working through the application process now, and we'll be sending out invites very soon to participants. Super groups, we've got for the uninitiated, super groups are subgroups of the clinical AI interest group, but we don't like the word subgroup because it indicates less interest. We prefer supergroup because it indicates more interest. We've got the Anesthetics and ITU super interest group led by Sandy Jackson, Medical Imaging and Computer Vision led by Alex Deng, Women's Health led by Bianca Shaw. And just to say, there's going to be a meeting on the 17th of July around that. So if anyone is interested, please do get in touch. And we're just about to launch, and you'll be getting an email very soon about a new pathology supergroup, which is going to be headed up by Chris Banerjee from the Turing. So really exciting there. In terms of upcoming events, we've got our next meeting will be in July, and that's with Pierce Keane, so an ophthalmologist who's been working in health AI for a long time. We're going to take a break in August, and then in September we've got another collaborative meeting with the Omics interest group. And we're really excited to say we're going to be hosting a tutorial by Professor Jeremy Wyatt, Professor of Digital Health, and he's going to be doing the first of what I like to call the Wyatt tutorials, which is going to be on knowledge-based systems. So a lot of learning for us all to do there. And then one other thing to just say is that in November, we're going to be collaborating with the EPSRC Neurotech Network and hosting an event in person at the Turing around that. Brilliant. Jenny, really excited to hear about the Data Science for Mental Health Interest Group, and over to you.
Organizer of the Data Science for Mental Health Interest Group here at the Turing. Just a bit of background about who we are and what we do. The aim of our group is to stimulate and align mental health research. It was founded by Professor Maria Liakata and Professor Terry Lyons. Our member comprised individuals from both academia and industry with a diverse range of backgrounds, including machine learning, mathematics, natural language processing, and psychology. And these are people who are actively working on or very interested in data-driven methods for mental health research and applications. And in terms of what we do, we hold regular events. This includes monthly meetings where we have talks from invited speakers from both within the UK as well as worldwide. During the meeting, of course, there are open discussions with the speakers about the talks, as well as within our membership. And in addition, we run a mailing list where we share information about related events in this area, such as workshops, conferences, and open positions, and so on. So our aim is that through fostering interactions between researchers and practitioners from all of these diverse backgrounds, we'll be able to kickstart projects using data for mental health, really leading to suitable clinical interventions to improve diagnosis, monitoring, and clinical outcomes. So in short, I think there's clearly a lot of overlap between our memberships, and there's a lot of potential opportunities for collaborations and knowledge exchange between all of us. So I really hope today's meeting will be a great starting point for us to get to learn more about what we do as interest groups and as individual researchers and practitioners. And if the topic of data science or mental health is something that interests you, if you would like to learn more, or if you already work in this area and would like to present your work or collaborate, we would love to hear from you. So yeah, very nice to meet you all.
Brilliant. Oh, thank you so much for that. Okay, over to Joe, who I think is going to introduce the next section.
Yeah, great. Thanks, Nick. And thanks, Jenny. So one of the really useful parts of being in a group like ours is obviously learning from other people that have been invited to talk, but also learning from each other and getting to know each other better to foster kind of cross communication and idea pollination, really. So we wanted to spend a few minutes in breakout rooms discussing 3 key questions, introducing each other to ourselves and get to know each other a bit better. So we're going to break out into groups of around 5. We're going to spend about 10 minutes in total. And we've got 3 key questions that we want you to answer when you're in your small breakout rooms. So the first question is, who are you? Second question is, where do you come from? And the last question is, what's your interaction with AI at the moment? Imminently, I think we'll be breaking off into breakout rooms. We'll post those questions in the chat so you have them ready to go. And it's over to you guys to have a chat.
Nick, do you want to go somewhere into another room? Should I put you in another room?
Yes, please.
Yeah. 5, 2, go. And Alicia, do you want to go somewhere?
Yeah, pop me in.
Okay. There we go.
Section. So I hope everyone had fruitful discussions, yeah, let's move on to the next section.
Great, sounds good. So I will now be introducing today's thematic session. Do we have everyone back from the breakout rooms, by the way? Yes?
Yes, we do.
Okay, perfect. Thank you. So I'll now give a quick intro on today's thematic session about AI and mental health. Our speaker is Professor Maria Liakata. She is a professor in natural language processing at Queen Mary University of London, an honorary professor at the University of Warwick, and an AI fellow at the Alan Turing Institute. Her Turing AI fellowship is on creating time-sensitive sensors from user-generated language and heterogeneous content, which involves developing new methods in NLP, as well as multimodal data, to allow the creation of longitudinal, personalized language monitoring. And she's also the PI of projects on language sensing for dementia monitoring and diagnosis, opinion summarization, and rumor verification from social media. And today she'll be giving a talk on personalized longitudinal language processing in the AI mental health landscape. So the floor is yours, Maria.
Hello, everyone. Can you hear me? Is it good?
Absolutely, yeah.
Yes.
Yeah.
Okay, great. So I want to make sure I'm in the. Can also see my notes. Oop. Sorry. I'll try once more sharing. Great. You can still see the screen?
Yes.
Okay, great. So thank you very much for the invitation to talk at the Clinical AI Turing Special Interest Group. And I really hope that my talk can help foster synergies across the groups and that we can learn from each other. So I will split my talk in 2 parts. So in the first part, I will talk broadly about work on AI and mental health. And in the second part, I will talk about the work we have been doing in the context of my Turing AI fellowship on personalized longitudinal natural language processing with a particular focus on mental health. So I have 20 minutes, I believe that's right? Until 12:40. So why is mental health an important area for AI? So according to the World Economic Forum, mental health disease accounts for 35% of lost work output, which is twice as much as cancer and more than cardiovascular disease. So it's clearly a very important, very important area to tackle. Now, there is work. So the clinical community is looking for new diagnostic tools and monitoring to help with demand. And there are signals that tell us that we can find useful information that tells us about human behavior from digital data, which makes AI very relevant. There is also a need to make interventions more effective. So there's some statistics from psychotherapy counseling that, in fact, I think only about, I can't remember now the exact percentage, but I think it was about 40% of, I should be fact checked on this, but my memory says that it is about 40% of people complete treatment. And so yes, so there is signal for diagnosis and condition monitoring available from language and other digital content. This makes AI a very fruitful area for improving mental health. So an important premise around here, around work on AI and mental health, is user-generated content. So as individuals, we produce large amounts of digital content, and this can be textual data in social media and online platforms, but also data from other devices such as smartphones and fitness devices and so on. So this is both a linguistic and other multimodal data. And we call all this data heterogeneous user-generated content. And this heterogeneous user-generated content contains behavioral cues. So a lot of the work in AI for mental health has been using this kind of user-generated content as its basis for different tasks. So so there's a lot of work being done in this area. Now, so I've tried to categorize here some of the main tasks within this space. So the most, I would say the most prominent task where most of the work has been done has been on classification for diagnosis and risk. So this kind of work typically takes social media data as input and either focuses on user level or post level classification. And there's usually, the goal is usually to obtain a diagnosis or a risk level for an individual or a particular post. And such tasks have been the main focus of workshops such as CL Psych. I don't know how many of you are aware of this. It's been it's a series of workshops that have been going on since 2014. So there's been work on trying and improving these kinds of classification tasks and grounding them more into things like electronic health records, but also clinician assessments. So more recently, there's also been interest in longitudinal model monitoring. So this has been focusing on prediction of mental health scales over time using user-generated content. And initially, language was not part of this. So kind of the early work from 2015 was on mobile phone mobility data from mobile phones. And more recently, there has been work on looking at changes in individuals over time from social media. And in fact, in the second part of the talk, I'll talk about the work that we've been doing as a group in this space. So another important area has been, which has been a lot of, so the references I provide are not in any way all-inclusive. They are examples of recent work within this area. So, so another important area is summarization. And summarization is usually around summarizing the content of mental health related posts on social media. So things like emotions and causes of distress as expressed in social media posts, but also on client therapist conversations. So so summarizing what happens in client therapist session. Another growing area within this space is that of dialogue systems and chatbots. So the bulk of the work in this space has been around improving therapy in client sessions or implementing therapy client sessions using AI technology. This is linked with sort of the next part, which is interventions, where the idea is to implement some kind of tool that has been developed by clinical mental health experts, and have it implemented as an AI system, and mostly a dialogue system for psychotherapy. But a lot more work needs to go into interventions. So a lot of work has gone into the tasks where, it's about modeling the information and trying to understand the information we have around individuals, and less has gone into actual interventions and how we provide interventions using AI. So one thing that permeates all tasks in this space is the need for high quality data sets and privacy preservation. So work has shown that it's really important how mental health is operationalized, and that there's actually lack of high quality data. So this is something that's really important, especially when people are trying to predict mental health based on social media, and how these kinds of predictions are grounded against real clinical assessments. So the data sets around in this area are very sensitive and can often not be shared, which to some extent has impeded progress. So the CL Psych workshop series have tried to mitigate this to some extent, and they've developed good quality data sets, and there's different ways of sharing these kinds of data with data sharing agreements. And also in the past 2 years, in 2021 and 2022, the shared task that they had was basically conducted in a data enclave, so in a secure environment, which meant the data didn't have to be shared with individuals. So there's all these concerns around how we can safely share this kind of data. Data is sparse, as annotation requires expert knowledge, and another kind of limitation within working with AI in this space is that we cannot really rely on large language models due to data sensitivity and concern about inappropriate generation. So these are kind of all important challenges within this space. So now I have about 10 minutes to talk about what we actually do within my fellowship. So this is a collaboration between different. It's funded by the UK Rhine PSRC. It's in a collaboration with academic partners from natural language processing and other disciplines such as mathematics, statistics, social sciences, psychology, and psychiatry. And we have partners which include mental health organizations and social media platforms. So what we want to do is we want to develop methods for capturing changes in individuals' language over time, and we want to be able to use these methods to create sensors for capturing digital markers from language and heterogeneous user-generated content to understand the evolution of an individual over time. And we want to be able to apply this technology to make a significant contribution to mental health by creating new tools based on these so-called time-sensitive sensors. So we have some particular use cases in mind. We work with data sets that involve mood instability, so things like depression and psychotherapy sessions and mental health fora. But also we work with data from people with dementia and look at cognition changes. So ideally what we would want to be able to deliver as sort of a product at the end, if you think about it in a product kind of notion, is that you would have some kind of tool that you would run on your phone or computer that would combine information from your conversation, messages, online interactions, and other digital activity you wish, and that could alert you, for example, that if you have bipolar, for example, that you have a manic phase imminent. And you could choose who you share this information with, whether you act on it or you have someone, a family member or carer who acts on this information. So in order to achieve this kind of this end goal, we address several objectives. So we have work that is looking at user representations from asynchronous longitudinal user-generated content. So mainly in NLP, we don't have a way of representing an individual through that is temporally sensitive. So someone can be represented through as embeddings from what they say. So embeddings that come from posts on the social media, but there's an important consideration here in terms of how you combine, for example, the linguistic data with the multimodal data from other devices that may be asynchronous, and also how you add temporal sensitivity to these representations. And so we've published some work in this area, and 3 more papers are currently under review and looking at user representations and temporality in user representations. A lot of the work that we have done already is around our second objective, which is in identifying normal states and anomalies. So an important part of personalized longitudinal language processing is being able to capture changes in an individual's representation over time. So once we have a way of representing the individuals, the question is how you capture changes in these representations. And so we've published as well some work in this area, focusing on moments of change, which is Tsakalidis and CL Psych, and then Tseriotou has developed a task that has developed on this task to add extra temporal information in how we capture changes in individuals over time using path signatures. And I think she's here, and we could discuss this further if people are interested. And then we have Anthony Hills, who's worked on how we actually identify interesting timelines for capturing changes, because these kinds of anomalies are actually very sparse. So you can't be annotating, for example, someone's entire history. So how do you actually identify beforehand what are interesting timelines to focus on? So then we have work on addressing data privacy and sparsity, especially in longitudinal data. And we work with a number of different data sets. Some are social media data sets that are span long periods of time, but can be quite sparse. in terms of and have no ground truth annotations. And we also work with sort of more specialized data sets, more fine-grained, where we have consented individuals who have given us the data that come from mobile phones as well as social media. And then for them, we have ground truth labels such as diagnosis and cognitive tests. And we have been working on how to both enhance annotations in these data sets, especially for the social media data, and also on how we can generate safely synthetic data that can be shared with others and also used to augment AI models and help with training. So Jenny, who's chairing today, is been working in the area of synthetic language data generation, and she should be able to talk to you more about her work if you're interested. And finally, a last objective is around real-world evaluation and creating interpretable summaries. So here, our vision is that you should be able to have this kind of big, call it a dashboard, that has different ways of presenting someone's data, whether these are from therapy sessions or their own data, social media data, and other data over time. And you have different ways of querying this data and summarizing it as well. So at the moment, we've published some work on summarization, which is more on opinion summarization, and we are at the moment at the point of looking at summarization of longitudinal mental health data, and Jayu Song is working in this space, and we're also looking at explainable summaries. So in this is currently in the context of rumor verification, but will also be very much applicable in the mental health data that we have. So I think this will be all I have enough time to say. There's so much more I'd like to talk to you about. Yeah, if you wanted to talk about any particular project, I'm very happy to do so. And yeah, I just wanted to say a few things about how we see this kind of work helping. So we believe that capturing moments of change in individuals over time will allow better monitoring of mental health in terms of different conditions. We have already shown that moments of change can be combined with other indicators such as symptoms and suicidality for better understanding of conditions. Indeed, we find that summaries of over longitudinal data and moments of change are very interesting to our psychotherapy partners. So this is an area we're exploring with them. And we also hope that this work will help platforms to better prioritize response to individuals and improve mental health monitoring pipelines by consented users. So finally, there are also considerations around ethics in AI in practice in terms of how we share the models we create and data, and how we mitigate unintended harm by others using our models. So we're engaging with colleagues in ethics and law to this effect. So thank you very much, and I'm very happy to continue the discussion.
Brilliant. Oh, Maria, that was a tour de force of mental health and data science. And obviously lots of it is incredibly applicable to the clinical AI interest group and the kind of the interests that lie there. One of the could we just, one of the things is, could we just discombobulate a term, which is, what's a path signature?
Oh, yes. So this is a particular method within rough path theory. So this is getting quite technical here. So it's not which essentially is able to summarize a trajectory, a sequence, a data series, and compress it without losing information. So it's been applied to different kinds of time series data.
I see. So kind of condensing down into what's the most important information, or do you lose things along the way?
So it's supposed to not lose information. I guess I mean, part of it is you have to do some compression before you use it. So there are some issues around dimensionality reduction before you use the path signatures. And so that's the point where you use information. But it depends in different areas, you may or may not need this dimensionality reduction. In language, you definitely do.
Brilliant. I'm going to go away and read a bit about rough path theory. I think it's the first time I've heard about it.
Oh, good luck. I don't know.
Alicia.
Tyler could say more if I don't know if you want to say anything more, Tyler, about are you there?
Yes, I'm here. Yeah, so basically, since we have to deal in our work with timelines of users that span over time, we found this method really useful in terms of producing graduated summaries of sequences. Those sequences don't necessarily have to be time sequences, but in our case or in finance applications, they are. And yeah, it's a very good way to kind of compress the information of what happened in the user's timeline when it comes to his or her linguistic content, and then be able to kind of classify mental health condition or a change on the user's behavior in this way, as opposed to just having a lot of information over time. Imagine hundreds of posts that a user might have produced. That's very expensive and that's hard to process. So that's how we use it, and we find it helpful in this use case.
I see. Because there's a statistical model called there's a model called UNet, which colleagues here have used in computer vision segmentation, which has one arm which is kind of contractile in order to establish what the most important parts of the image are, but loses some information to do with location, and then one that's expansile that allows you to then keep those elements in focus, but then establish where those are within the image. Is it a kind of similar kind of concept?
I haven't come across this method, but I think that in principle it's different, because this has to do with basically representing a sequence of data in a new feature space, and this is grounded based on the rough path theory. So I'm not sure that this method is, but yeah, we'll look into it.
Yeah, so Professor Terry Lyons, who actually introduced path signatures and is a main person in rough path theory, he's worked in lots of different applications. So language is one of them.
Brilliant. Sam, you've got a question.
Yeah, can you hear me well or not?
I'd say we can hear you satisfactorily.
Satisfactorily, I think I will run with that. Yeah, I just want to say, I think UNet is mainly image segmentation model, so I don't think it would work with vectors that you might need for NLP. But I'm sure there are more clever people in the chat to clarify that.
No, I was just alluding to the fact that it's, that you basically take, you condense an image down into a set of features and then kind of do something with it. Just because I'm aware that there's, we're quite a broad church in the clinical AI interest group, a lot of clinicians, some of whom have more or less experience of AI and models and things. So just trying to learn a little bit as we went along. But it's a really good point, Sam. Thank you.
Yeah, I mean, I'm mentioning the decoder encoder kind of feature of UNet. That's what we're trying to allude to.
Brilliant. Perfect. Alicia.
Hi, it's Maria. It's just fascinating stuff. My question, I might have missed it, is how are you assessing against some sort of grounded truth, and what is that, particularly for that user-generated data, and trying to pick out the signals from the noise? I'm just interested in how you're doing that.
So in terms of how we actually annotate data for evaluation. So for the identifying the moments of change, there are two different data sets. One was annotated by non-clinical experts, but they had very detailed guidelines in terms of what constitutes a change in mood. So we considered switches and escalations, which are both significant in the psychology literature. And so then the changes identified by the model are both tested. The model is both trained on these annotations and tested, but you could also just use them for testing. So if you wanted to have a different kind of model that was unsupervised in terms of finding anomalies, you could still use this kinds of data for testing. And then in terms of the grounding against clinical assessments, the data set we developed for CLPsych last year had annotations on user risk for suicidality, which were provided by clinical experts. So they were basically shown a window of posts, and they would have to decide whether a post, whether actually given this window, the user was at risk of being suicidal. So we do try to have this combination of clinical and clinical annotation. So a lot of the criticism that Munmunde Chuduri and her she's been working a lot in the space of AI and mental health has made is that a lot of people use things that are proxies and not actually actual clinical assessments for both training and evaluating these models. So yes, so we try to not do that, well, as much as, at least for evaluation, be grounded in clinical assessment.
Thank you. Sam, are you still? Is your hand still up? Have you got another question?
Sorry, I rolled my.
No probs. Rama.
Yeah, actually, thank you so much to Maria, for wonderful work you are doing. So I'm also working on the same area. So developing a mobile application. That application, with one click, the user is able to know their mental score. Okay. I was having a past experience to understand about our Oxford True Colors framework. Okay. That is a little bit of legacy. Okay, but still I'm trying to find out how accurate it would be. So I would like to, work with you to make it more accurate. And, there are 3 stages actually I'm working. First stage is to gather their social media conversations. Second stage is to record their, the conversation with their friends. Third stage is, the video conference by facial expressions. And, these 3 stages, I would like to make sure that their mental health score is in good or, need an attention. Okay. So this is what exactly at present, we are focusing on that. I'm very happy to see that you are also working on the similar lines.
Great. So you're getting human annotations for this. How are you getting your assessments?
At present, actually, I'm using the Google, the what I can say NLP algorithms we are using. Based on that, the sentiment scores we are extracting. The sentiment scores accuracy right now, it is not more than 60%. What it means is that, hey Rama, how are you? If you say, okay, I'm doing. So based on that, it will define one score. Okay, but that score, depends on various, the time sequence, right? And other parameters. We are doing a lot of trials, okay, to make sure that the score should be accurate. We are at an early stage of it.
Okay,
So
great.
yeah,
Okay, glad.
looking forward to connect with you or your team so that we can leverage and we can collaboratively build the better solution.
Great.
Yeah, it would be great if you are able to, I dropped a personal message to you on this chart. If you are able to let me know how we can really, work together.
Okay, thank you.
Brilliant. Excellent. Sounds very fruitful. Hugh.
Hi, thanks. Thanks, Maria. Really, I'm a jobbing clinician and a bit of an old-fashioned sort of clinical scientist. Really interesting what you were saying, but leading on from Alicia's question, I kind of find myself dwelling on the notion of a kind of ministry of mood. There are some Orwellian concepts that aren't too hard to extract from this, and to the point then about grounded truth. In old money, one would have a derivation cohort and a validation cohort to identify what was a strong enough signal to make a binary decision. But it seems to me that's not what you're doing, or have I misunderstood it? And if so, is that part of the process you anticipate?
Sorry, so we don't try to make binary decisions, and we are kind of trying to steer away from diagnosis. So we prefer to do monitoring in terms of identifying changes and also explaining the reason behind the changes, so summarizing the context around the changes. So I don't know whether that helps clarify things for you, or maybe.
I can see over a diagnosed individual, longitudinal monitoring could give soft signals about impending state change. Mm-hmm. But is your inference that you're confined to that at the moment, is what you're saying effectively? Because otherwise one could take anyone's social media and actually ascertain whether they had or had not got a mental state of some sort. And
we want people to be opting into this kind of thing, to not being monitored without knowing that they're being monitored, of course. So this would be someone choosing to have their own personal monitor on their device. We don't advocate in any way monitoring individuals. We wouldn't want to do that and it's a danger. So this kind of technology could be taken by others and used to monitor people. So for example, companies could monitor their employees for mental health conditions. And so we are trying to explore how to mitigate this kind of risk by having kind of clear agreements if we share data and models. So at the moment we're not sharing our data without some kind of strict agreement, an NDA, in terms of how it would be used and that it would strictly be used for only that purpose. But it is an open-ended question how you mitigate for this kind of monitoring.
Thank you.
Brilliant. We're getting close. So Ludmila, maybe a quick question.
Yeah. So maybe it's a stupid question because I'm really not in the field. I'm an astrophysicist, but do you use data from the hospitals?
So the work that I described is not with EHRs, but you could combine this with electronic healthcare records. Mm-hmm. And this is in a project that I'm currently collaborating with King's College London. We do have this combination of electronic health records and social media data. So yes, ideally you would also want to have ground truth from EHRs. I guess one of the issues is that the EHRs would be a lot sparser than kind of the changes you would see on sort of social media or user-generated content.
And I suppose that the dashboard for summarization might well be a kind of tool that could be used within a hospital setting as well, to inform clinicians and allow them to monitor patients in the community.
Yes, we'd hope that.
Adebisi?
Well done. Thank you. So I'm impressed by the work of Maria and the fact that they are building a solution that help people to identify changes, not to diagnose. So I look forward to this kind of solution that will be useful for people in Africa. My name is Adebisi Abiodun. I work for a startup called iRespond Africa. We are majorly into mental health. We want to improve mental health in Africa, in promoting it for people of Africa. So one of the things that we want to do is building a solution that will help people to know about the status of their mental health, and not to diagnose, but at least to be aware of the state of their mental health and seek for appropriate help from professionals, that's psychiatrists or clinical psychologists. So I don't know, I'm also into data engineering and data science. So I don't know if there's a way that we can work together. Yeah.
Well, thank you. We do want to, we have a cohort of stakeholders who we like to show what we're doing and take advice from in terms of making our models and tools more useful. So email me and we'll add you to our stakeholders mailing list. And so the next stakeholders meeting you can attend and you can be part of our stakeholders.
Yes, can you send your email address?
My email address. So yeah, I'll put it here in the chat.
All right. Thank you.
Awesome. Well, thank you so much to Maria. Thank you for your talk. Thank you also for answering all of our questions as well. Before the Zoom call ruthlessly cuts off, I'll just close by saying thank you very much again to the Data Science for Mental Health group for collaborating with us today. And the next Clinical AI meeting is on Tuesday, the 11th of July at 12 p.m. And we'll be hearing from Piers Keane on a talk entitled Transforming Healthcare with AI, Lessons from Ophthalmology. Jenny, would you like to just close by talking about the future events for data science for mental health?
Yes, sounds great. So again, thank you very much for organizing the joint meeting today. For the Data Science for Mental Health Interest Group, we will have a July meeting. It's on Thursday, the 20th of July. There's a talk on psychotherapy personalization, and I think we will have more speaker details confirmed soon. So please check our website or shoot us a message and we'll add you to the mailing list. Thank you everyone for coming.